Peace, 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 peace. What's going on? What's going on? Peace to Brother Chauncey. Peace. So tonight's topic is very intriguing because I never heard a question like this before until I read the article. So tonight's topic will be the question of how will human be decomposed on Mars? So before I go into the article, I want to shout out to the people that's been subscribing to the channel, checking out the channel, hitting the notification bell. Thank you guys so much. I really appreciate y'all that's been supporting and whatnot. So yeah, and then I'm gonna also get into the hot topic. Hopefully later on Tuesday, about this whole R. Kelly trial. And just get some inputs on it, because I got some things to say. I've been holding back on R. Kelly for a while, but now that this man was found guilty, I'm going to speak on that on Tuesday. But I want to get into this article. Now, many people may not be too much into science, especially astronomy, but I thought it was something that I want to bring in the spotlight to talk about, to have as a discussion here. So the question would become, how would human be decomposed on Mars? Well, let me read the article, and then I can go a little further into it. And then also I want to be able to bring some information in regard to the Mars and like the temperature and stuff like that. Okay. And there's some questions I have to ask as well. All right, so let's go ahead and get to the article. All right. So according to this article, it's from astronomy.com. It says, how will human decompose on Mars? The red planet's unearthly environment will play a key role in how future astronauts and Martian settlers handle their dead. Well, let's see. Mars has dominated recent headlines as the newest generation of robotic explorers aims to uncover its secret. But one day, robots won't be the red planet's only inhabitant. Human explorers will be next. And whether we're sending a small crew on a round trip or shunning colonists with a one-way ticket, someday, somehow, someone will die on Mars. And because of the potentially prohibitive logistics and cost of transporting their body back home, it might very well need to stay there. So what would happen to a dead body on Mars? All right. Peace, Brother Vinyasa, Brother Gullah. Peace to you. So that's a good question. Let's see what they're going to talk about. So it said how decomposition works. Humans evolved on Earth, and our home planet is the perfect environment for us, alive or dead. On Earth, human remains eventually decomposed as the environment recycles the body's biomass, the organic material that makes us up. Certain organisms basically have evolved to exploit the biomass of dead organisms. That's just their thing. Their niche, says Nicholas Pasalacqua, program director of the Forensic Anthropology program at Western Carolina University in Callaway, North Carolina. Here's what basically happens when a person dies and decomposes. According to Melissa Connor, a professor of forensic anthropology at Colorado Mesa University in Grand Junction, Colorado. Early on, the body cools and the blood begins to pool due to gravity. Rigor mortis, or temporary stiffening of the muscle, sets in. Then cells begin to break down as the body owns enzymes destroy them, a process called autolysis. Then purification occurs as the bacteria that help us digest our food keep right on trucking along. It's autolysis and putrefaction that cause things like discoloration and other skin changes, as well as bloating. Scavengers such as insects, birds, and other animals, and later fungi also move in, taking care of the rest of the cleanup. Connor does note that decomposition is a continuum in which these processes may overlap. So this isn't necessarily a strict step-by-step process. On Earth, the main factor that affects decomposition is temperature. Palalasqua says temperature is really an important factor for the things that metabolize, that eat human tissues, he says. So when you think about insects as a primary kind of scavenger of human soft tissues, insects activity is really temperature dependent. Temperature is a factor for another reason as well. Sublimation occurs in freezing environments. The frozen water escapes to gas without going through the liquid form, Connor says. The same way wet clothes can still dry hanging outside the winter, so in freezing earth environments where water sublimates and the cold stops process, such as autolysis, simulation, desiccate remains and create mummies, she says. All right, now let's go down here where it says Martian environment. Although Mars may have looked more like Earth in the past, today it is a cold, dry planet with an exceedingly thin atmosphere composed of 95% carbon dioxide and only 0.16% oxygen. Mars' average temperature hovers around negative 81 degrees Fahrenheit, which is negative 63 degrees Celsius. But this can vary by location and season. For example, in October 2020, Mars InSight was reporting highs up to 24 Fahrenheit, negative 4 C or Celsius. During the warmest part of the day, and lows of negative 140 Fahrenheit, negative 96 Celsius at night. And there is, of course, no liquid water and no known living organism on the red planet surface today. All right. So then that's many questions that come to mind. Now, according to the article, it says that Mars is pretty much cold. It's at a very cold temperature. So the question becomes, would humans be able to withstand being under a negative temperature in a planet like Mars? If we cannot go to Antarctica, right? Anybody that knows about Antarctica, it is a continent, but there's barely any human life there because it's very cold. Now, if you cannot live on Antarctica, how can humans go to Mars and be there? How long will you survive? That's the question. Be able to survive for a day? What is your body temperature? Can your body withstand a cold temperature like Mars? If so, how long it's going to last you? Okay, now if it lasts a day, would it last 2 days? And if it does last for a day, would you turn freezing cold? I mean, mention that you'll turn out to be like a mummy or something. So is any other organism life on there besides? Well, it says there's no known organism. So how do we know for a fact there's no known living organism that's up there on Mars? How would you know that? You may not see them, but are there any type of bacterial organism that's there? You know, organisms that we cannot see with the naked eye. So how can What human would want to be on Mars and be there for a certain time period? Would you be able to adjust to that? Why would you want to be decomposed on Mars? I mean, it's an interesting article, but then it's an interesting question. As a matter of fact, let's look up some information about Mars real fast, and then I'll go back to the article. So let's look up some information about the planet Mars. Okay. All right, so I'm gonna go ahead and post up the website. Mars fats, life, water, and robots on the red planet. Okay. Space.com. What we know about the red planet. February 7th of 2019. So it says Mars is the fourth planet from the sun, befitting the red planet's bloody color. The Romans named it after their god of war. In truth, the Romans copied the ancient Greeks, who also named the planet after their god of war, Ares. Other civilizations also typically gave the planet names based on its color. For example, the Egyptian named it Herdesher, meaning the red one, while ancient Chinese astronomers dubbed it the fire star. So if it's supposed to be a fire star, then why would it be so cold? Why would the temperature be so cold and be at a negative degree Fahrenheit and Celsius? That's very cold for it to be a fire, right? But let me go ahead and continue. Anyways, so let's look at physical characteristics. The bright rust color Mars is known for is due to iron-rich minerals in its regolith, the loose dust and rock covering its surface. The soil of Earth is a kind of regolith too, about a bay one loaded with organic content. According to NASA, the iron minerals andesite or rust cause the soil to look red. The cold, thin atmosphere means liquid water likely cannot exist on the Martian surface for any length of time. Features called recurring slope lining may have spurs of briny water flowing on the surface, but this evidence is disputed. Some scientists argue that hydrogen spotted from orbit in this region may instead indicate briny salt. This means that although this desert planet is just half the diameter of Earth, it has the same amount of dry land. The red planet is home to both the highest mountain and the deepest, longest valley in the solar system. Olympus Mons is roughly 17 miles, 27 kilometers high, about 3 times as tall as Mount Everest, while the valley's Marianas system of valleys, named after the Mariner 9 probe that discovered it in 1971, reaches as deep as 6 miles and runs east-west for roughly 2,500 miles, about 1/5 of the distance around Mars and close to the width of Australia. Okay, so let me skip down just a little bit and I'm gonna go back up. Mars also has the largest volcanoes in the solar system, Olympus Mons being one of them. The massive volcano, which is about 370 miles in diameter, is wide enough to cover the state of New Mexico. Olympus Mons is a shield volcano with slopes that rise gradually like those of Hawaiian volcanoes, and was created by eruption of lavas that flowed for long distance before solidifying. Mars also has many other kinds of volcanic landforms, from small, steep side cones to enormous plains coated in hardened lava. Some minor eruption might still occur on the planet. And then go back up. It says scientists think the valleys monorails formed mostly by rifting the crust of, rifting of the crust as it got stretched. Individual canyons within the system are as much as 60 miles, 100 kilometers wide. The canyons merge in the central part of the valleys morinus in a region as much as 370 miles wide. Large channels emerging from the end of some canyons and layered sediments within suggest the canyons might once have been filled with liquid water. All right, so now we know that the Mars has some form of volcanoes, right? Okay, but how often does a volcano take place in Mars? And would that even save human life? I don't think so. So again, if there is no water, right? If there is no heat, what other reason would you have to go on Mars? I don't know any human would want to stay on Mars. So how would you decompose? Okay, in my theory, if anybody watched Mortal Kombat, if you know about the movie Mortal Kombat, right, you know Sub-Zero. Sub-Zero, what does he do when he want to combat his enemy? He freezes them. So he takes them and he blows out cold air and it freezes his enemy. So that's how it is. So basically, if you know the temperature is very cold, it's pretty much below zero, because zero is the highest number. If we're looking at whole number, I know everybody learned about whole numbers, real numbers in school. Zero is considered as a whole number. Anything that's at a negative is below zero. So anything that's below zero, that's dangerous. So that means that you probably won't even decompose instantly. You'll just freeze up. You'll just be like a mannequin, a frozen mannequin. That's what it'll be. I mean, you wouldn't necessarily decompose like you would on Earth. You know, your body going to decomposition and all the other organisms come in and feed off of you, or you go back to the ecosystem, etc. No, so that means that you'll be instantly frozen. You'll instantly freeze up. So if you take 1 foot out and walking on Mars, you'll instantly freeze. So there really wouldn't be no decomposition. You'll end up being like the enemies of Sub-Zero. Freeze up. You'll be a mannequin. That's just my theory on it. Now, my theory could be wrong, or my theory may not make sense. But just reading this article itself, I was able to just come up with some form of conclusion that you would just be frozen. You'll just stand still like this. You won't be able to move. So you won't be able to move. You'll just stand there, and everybody will be looking like mannequins. That's just what I think. I mean, that's what I perceive on that. Let me see what else I could read from this article. Let me see what else I can read from this article. All right, peace, Brother Rashid. How you doing? All right, so mommies on Mars. It says all of this is why Connor and Pasalacqua agree. A body on Mars, if left outside or even buried in those loose Martian soil, will probably dry out and mummify. The first few stages, algor mortis, livor mortis and rigor mortis would still take place, Connor says, but there might be almost no other overt signs of decomposition, she adds. Autolysis and purification would continue until the body froze. With one significant caveat, most of the bacteria in our body are aerobic, meaning they need oxygen to function. On Mars, only the anaerobic bacteria that don't require oxygen could proliferate until freezing, which means purification would be severely limited. After freezing, the body would dry out as its moisture sublimate away, leaving a well-preserved natural mummy behind, the lights of which might have made the ancient Egyptian jealous. The desiccated tissues would likely be very stable for an infinite period, Connor says. Well, I don't see how it can dry out. I mean, because if it's very frozen on Mars, then how would it be able to dry out? Unless they're talking about that the body will be able to shrink, but I don't see that happening either. If you're in a frozen area that's below zero, your body is not going to be able to shrink. I don't see your body being able to shrink. It's going to just be frozen. So the only way it's going to dry out and gain some moisture is if it's some type of exposure to thermal energy. So if there's some exposure to the thermal energy, then it will make sense. But let me continue. Okay. If you think about those peat bodies from the medieval period, I would assume that it would be kind of like that. Those bodies are remarkably well preserved and are mummified in parts because peat bogs are oxygen poor environments, which again limit the body's own breakdown and prevent most organisms from coming in and finishing the job. All right. So I'm just going to skip down here. It says if you think about a body going from something that looks like a person to something that looks like a skeleton, I don't think you're really going to get that in the Martian environment. Bodies might dry out and mummify, but I don't think much else would change. And this comes from Passalacqua. Dust to dust, exceptionally preserved Martian mummies might sound like a cool idea, and the easiest and most straightforward option is indeed to bury the deceased. However, if human settlements on Mars really take off, cemeteries may require a bit of zoning planning and forethought, as the bodies in them would not decompose, prevent the reuse of plots. And then goes on to say, cremation, while a popular and efficient body disposal option on Earth, is probably not the best method on Mars. That's because cremation requires keeping a chamber in excess of some 1,000 Fahrenheit, which is 538 Celsius, for several hours, and turn requires immense energy input. In an environment where such fuel could be limited, that's a costly solution. That's a huge amount of energy that's just wasted to burn a body and not used for anything else. And this comes from Passalacqua speculates. After all, you're in this weird Mars environment. You probably want to be as economical as possible in all things. But both burial and cremation have a significant downside, the loss of potentially precious biomass. Remember that on Earth, decomposition is the ultimate recycling program, returning that biomass to the environment that we're in. On Earth always wants to exploit biomass as much as possible, but the Mars environment's not going to be able to exploit those resources at all. It's just going to be lost resources for everybody. And this comes from Passalacqua, whatever. It says, in a place where bringing your own resources come with a high monetary and physical cost, is that really ideal? And then goes on to say, perhaps the best choice could be to recycle that biomass as would occur on Earth. It's worth knowing, of course, that processes like embalming largely halt decomposition. So all discussion on decomposition on Earth refers to non-embalmed remains. In that case, it might be best to bury a body not outside in the Martian soil, but instead in a temperature and moisture control, Earth-like decomposition greenhouse organisms such as insects and fungi to eventually turn that body into usable fertilizer or soil. Of course, those organisms would need alternative food sources when there are no bodies to consume. And this comes from Pasalaqua. However, there is a scenario that could change all of this. With aerobic bacteria unable to function, starved of oxygen in Mars atmosphere, our anaerobic bacteria could adapt to the Martian environment, perhaps making it possible for bodies to decompose. After all, evolution is an ongoing and can happen quickly, Connor says, noting, for example, the rapid appearance of COVID-19 variants throughout the pandemic. So I would not be surprised if something that we carry from Earth evolve quickly to take advantage of a food source, particularly if there was a cemetery of colonists. Today, the only remains on Mars are those of defunct robotic missions, sparsely dotted the landscape as they gather layer after layer of rust red dust. But when humans arrive, there's clearly a lot we'll need to plan for, including what to do with our dead. All right, and so that's it. Again, so that shows, based on that article, the answer is the body won't be able to decompose. And if it does decompose, it would take much longer for the decomposition to take place. So at that point, the body is just going to be frozen. It's just going to freeze up. It's going to look like a mannequin. That's what it's going to look like. It's going to look like the Sub-Zero enemy. So it's not going, the decomposition is not going to take place anytime soon. And it wouldn't be a wise idea to die on Mars. It wouldn't be a wise idea to go ahead and die on Mars. You're better off dying on Earth. I mean, although, and I mean, it sounds sick, but you at least have a natural process going. You understand the ecosystem. So this itself dispels this whole mythology that we get from religion too. All right, especially when it comes to decomposition and all that stuff. When you die, the question is, people always question, well, what is soul? Does the soul really exist? Or is it just abstract idealism? What is soul? We don't know what soul is. So we use it from an abstract point of view. But what we do know with your body is going to go into decomposition on Earth, and your body becomes the mineral, the vitamins, the resource, and all those components, the atoms, the tissue, all of that is going to be available for other organisms, whether it be the plants or the animals or the bacteria. You go back into the soil. And the process happening all over again. So that part of your body helps to fertilize the other organism. It helps them to survive. So just like you depend on organism depends on you. So we live in a recycling process here on this planet. All right. So it don't matter what you do, you can mummify yourself. Even through mummification, you can still be decomposed because the bacteria And all the other microorganisms are going to find a way to get into your body. The maggot is going to find a way to get in your body, because that's what attracts them. The maggots is what turns into flies. Okay. And do you know how flies survive? They survive off of decomposition. So either way, you really can't get away from that. You can't get around that. All right. But on Mars, you're not going to be able to decompose. You're not going to go through the process of decomposition. So therefore, there is no biomass. There is no ecosystem. That's what the article is saying. At least there is no ecosystem available, because there is no known living organism available on Mars, according to the article. So you're stuck. And as far as other planets like Jupiter, Pluto, and Mercury, and Saturn, all these other planets, Uranus, Neptune, we don't even know. Venus, we don't even know. We don't know what is out there. That we don't know if they have other human life. That's something that we have to look into. Or hopefully there'll be some articles coming out about those planets. But if there is life, the life of theirs is probably different from the life here. There'll probably be a whole nother species, a whole nother organism in all these other planets. But this just me. I feel sorry for anybody that goes up there to Mars. Well, actually, I don't. I mean, if you go up there to Mars and you trying to walk on the ground, you guys to be asinine to do so. You guys to be you gotta be pretty insane to do so. I mean, there's no anybody with logic knows not to walk on ice, ice cold temperature. If you can't survive in Antarctica, there's no way you can survive in Mars. It's just not gonna happen. So that means you're gonna die instantly, especially when there's no water and food. You're gonna die instantly. Let's see. The Danakil Africa is the closest landscape on Earth to the moon. They're supposed to be studying microbiology there to see about these very things. So, okay, what country is Danakil? As a matter of fact, let me look that up. Let me look that up while I'm on here with you guys. Hold on. Let me see the question. Would it be arrogant of us to think we are the only life forms in this galaxy? I mean, yes, it will be very arrogant. But at the same time, the question is, we don't know if we're the only life form. Are we the only ones? That's the question. We don't even know. We don't know unless we find out, unless there's some form of observation. If there's no form of observation, then we can't really say there's other life on the galaxy. We can be hypothetical, but where is the validation at? Where's the observation? Because you have to be able to observe other planets. And many of us ain't got the fortitude to go to other planets and check out other life forms out there. So the only people that we can rely on for that nature is either astronauts, NASA, astronomers, astrophysicists. That's who we can rely on for that answer, because at least they have a better chance of doing the research or being able to discover things before we can as average individuals, as civilians. So we don't know if there's other life forms on other planets. We can't be for sure, but we know, but I do know based on the article about Mars that There is no known living organism, and it can't be any other living organism if the temperature is below zero. If the temperature is below zero, then it's hard to have other organisms living on other planets, because it will not, the chances of survival is very slim. And that means, and if they do survive, they won't survive very long. They won't survive very long on other planets that is below zero temperature, or planets that's at 1,000-degree temperature or 500-degree temperature, especially without water or food. So it's very hard to survive, because that's the main thing that we have to have as human in order for our survival. We're not breatharians, okay? We can't just survive off of just breathing. We got to have the minerals, the vitamins. We got to have some food consumption in our system. Look for Danakil Depression. Let me look up Danakil Depression. Let's see. All right. All right, so let's look at Danakil Depression. The Danakil Depression is the northern part of the Afar Triangle or Afar Depression in Ethiopia, a geological depression that has resulted from the divergence of three tectonic plates in the Horn of Africa. Geology. The Danakil Depression lies at the triple junction of three tectonic plates and has a complex geological history. It has developed as a result of Africa and Asia moving apart, causing rifting and volcanic activity, erosion, inundation by the sea, the rising and falling of the ground have all played their part in the formation of this depression. Sedimentary rocks such as sandstone and limestone are uncomfortably overlain by basalt, which resulted from extensive lava flows. And the location, the Danakil Depression is a plain approximately 200 by 50 kilometers, lying the north of the Afar region of Ethiopia near the border of Eritrea. It is about 125 meters below sea level and is bordered to the west by the Ethiopian Plateau and to the east by the Danakil Alps, beyond which is the Red Sea. The area is often referred to as the cradle of humanity. In 1974, Donald Johnson and his colleagues found the famous Australopithecus fossil Lucy, which has been dated 3.2 million years old, and many other fossils of ancient hominids have been uncovered here, prompting many paleontologists to propose that this area is where the human species first evolved. I remember hearing the story about Lucy and her fossils being found in the area between Ethiopia and between Ethiopia and Eritrea. But let's see what else we can find. The features. So the Danakil Depression is the highest place on Earth in terms of year-round average temperatures. It is also one of the lowest places on the Earth at 100 meters below sea level. And without rain for most of the year here, the Ashwa River dries up in a chain of salt lakes such as Lake Afria, never reaching the Indian Ocean. Mount Ayahu is the westernmost and older of two volcanoes at the southern end of the Danakil Depression. The other active volcano is Eta or Erta Ali, is one of several craters, lakes of lava bubbling from the Earth's mantle. Additionally, the area contains the Dole Sulfur Spring or hot springs. This These wet environments at the Danakil Depression are being investigated to help understand how life might arise on other planets and moons. Many microorganisms living here are extreme morpholytic microbes of a major interest to astrobiologists. Nonetheless, in October of 2019, scientists reported that the terrestrial life forms, including extreme forms of archaea microorganism, were not found to exist in the very hot, acidic, and salty condition present in some parts of the Danakil Depression. Hmm. Hmm. So, um, so somewhere in that region, there's a sound like to me there's a lot of volcanoes taking place and it's extremely hot condition. So by it being extremely hot condition, that would be hard for human. It'll be hard for humans to survive there too. And if humans did live over there in that area outside of Eritrea and Ethiopia, if they lived in that area, then they'll extremely have a hard time surviving. So especially if there's volcanoes constantly happening all the time, they gonna end up just turning to ashes. They gonna end up being naturally cremated if they try to live in that area. But it is real pretty. If you look up pictures, it looks wild there. This earth is big, cool place, and lots of stuff could be exposed to our baby on earth alone that makes it worthwhile. Yeah, but it is some areas that's too dangerous to go to. So um I appreciate that information. I really do. But as far as human survival, that's gonna be extremely hard. If you survive in an area like as Danakil Depression and trying to survive there where it's extremely hot temperature, that sounds like a natural cremation because you're gonna end up being naturally cremated. I mean, how can't you survive under a very hot temperature? And better yet, this is what I try to figure out how can people survive in Phoenix, Arizona? Because Phoenix, Arizona, they have no moisture. So what that means is dry air. So if you stand outside in the sun in Phoenix and you're under dry air, you're burning up. Your skin is gonna burn instantly. You can't just stand out there too long. You gotta have like 4, 5, 6 gallons of water in order to survive in Phoenix, because that's how hot it is. So if it's very hot in Phoenix, right, and the temperature rarely changes, then imagine trying to stay in an area like Danakil. Try to imagine staying in that area and add the temperature from Phoenix and multiply that in Danakil. Again, that's natural cremation. You looking to be cremated because you ain't finna survive. So it's no wonder in certain areas of Africa that it gets extremely hot because they're around areas that has a volcanic eruption. So and then going back to what you said, as far as microbiology, there might be some form of microbiology there. Who knows? Because there are certain organisms that can survive under that type of temperature. But as far as human life, that's going to be extremely hard because the human may not, and if the human did step into that area, they may not last very long. They might probably last for a day, not even a day. They probably last for 2 seconds or 3 seconds and they collapse and die because you can't survive in that type of temperature. So to say all that, there's areas of this planet or this universe where it's extremely hot and there's areas where it's extremely cold. So there's areas of the universe where it's extremely cold, and there's areas where it's extremely hot. And there's little to no human life or human contact on certain planets. Certain areas. Because the human body is not designed to be able to survive in extreme heat or an extreme cold temperature. And speaking of cold temperature, let's go back to the argument about Pangea, which is so many people made the argument about Pangea, right? Pangea exists about around 500 million years ago or 350 million years ago. So if Pangea exists around that time period, right? And during that time, it was the snowball effect. And if you know about the snowball effect, that's when the temperature was extremely cold. How can humans live around that time period, organism live around that time period when it was under the snowball effect? How could you be able to survive? So this is what people got to question their logic. If you say human exists 350 million years ago during the time of Pangea, the question becomes, how would they survive during that time period under extreme temperature during the snowball effects? How would they survive? That's a good question to ask somebody who's into that pseudo-scientific knowledge. How will humans survive in an extremely cold temperature? And you cannot use the argument breatharian because it's not going to work. How would the earliest human would have survived in extreme cold temperature? True, I want to go in a cave, but too scared of collapsing on me. Otherwise, I'll do. Well, tight places is a big no. But then crystal caves look pretty. I don't care how pretty it looks. If the temperature is too hot or way too cold for me, I ain't going. That means Morgan Freeman was just turning old enough to drive roughly 500 million years ago. Oh, wow. What a great analogy right there, Morgan Freeman, in that analogy, though. But yes, this is the question that I would ask somebody who's into that pseudo-scientific knowledge, where if you're going to make an argument about humans like being on Pangea, what type of humans are you speaking of? Because you can't talk about Homo sapiens. Homo sapiens was not even around then. So what type of humans are you speaking of? Are you speaking of the hominids? What are you talking about? The Ardipithecus, Australopithecus, Homo erectus, the hominids, the Neanderthals, the Denisovians? What type of humans are you speaking of? And how can't you prove it? What conclusive evidence do you have to prove that there was human life on Pangea 350 million years ago? And how would they survive in an extreme cold climate? Was their skin tough enough to survive in that type of climate? What type of food were they able to eat? What did they drink? They couldn't be drinking water, so what could they be drinking at that time? These are questions I would ask. Peace, brother Centavo. Thank you, brother Centavo, for coming through. Yeah. But I know this topic is kind of boring. Yeah, it's not one of your average topic to talk about. I know it's one of those boring ass topic. Yeah, it is boring, but again, it was just very intriguing, and it was something I ain't never heard a question before about human decomposition in Mars. I never heard this question. I never heard people ask these kind of questions until now. So again, it's not one of your average topics to talk about. I mean, unless you the type that like to get high, smoke you some weed, or do you some shrooms, some LSD or something. If you smoking some weed or doing some LSD, then you might just have some random question coming to mind. You might ask some random stuff that your peers might think is weird, or it might be stupid, or they might think that something's wrong with you. Like, what the hell is you talking about? Where's your mind going? Are you tweaking too much? I mean, yeah, this is the kind of question that you ask when you get high. When you get high and you smoke you some good ass weed, although I'm not a weed smoker, but if you smoke you some weed, you might sit back with your friend and you might ask, well, damn, how do they know that humans been around for 350,000 years? How do they know how long the sun been around? How do we know that the sun did not exist? How do we know that the sun didn't have no... How do we know that the sun did not have any... How do we know that the sun is not eternal? How do we know that the universe is not eternal? How do we know this? I mean, these are the kind of questions that you might ask when you get high. Well, dang. What if there's no such thing as life and death? You will ask some strange questions. Trust me, I've been around people who was high for marijuana. They asked a bunch of strange questions. I mean, you looking like, I don't have no answers, so why are you asking me? I don't know how to tell you this. What the hell you asking me for? I ain't no scientist. But, you'll just come up with random thoughts. Can't you bite your own teeth? No, you can't bite your own. That's a good question, but no, you can't bite your own teeth unless you're chewing hard. Now, if you're chewing too hard and one of your tooth starts to crack, then yeah, that can happen. You can crack your own tooth. That happened to me. I mean, I was chewing on something, my tooth in the back started cracking, and I ended up, chewing one of my tooth, and I had to. That was not a great feeling. So, why is water wet? That's a good question. Why is water wet? And that's a good question. Well, we know that water is liquid. But water can also turn solid. And what happens when water turns solid, it becomes what? Ice. So when it becomes ice, that makes it solid. So you go from a state of liquid to solid. But that is a good question. Why is water wet? Yeah. Right. You can bite them if they fall out. Exactly. You can bite your teeth if this shit falls out. And you don't know what the hell you chewing on until you look down, you see some little bones crushing. Because that's all your teeth is. Your teeth is nothing more than bones. That's all it is. Your teeth is just your bones. It's just your bones. Yep. But let's see. You know what? While I'm on this subject about was it Danakil Depression? Let's see what they talk about the Danakil in humans' life. Oh yeah. Oh yeah. So going back to the article, or going back to the source that I was reading from Wikipedia, where it talks about being pure acid. If it's pure acid, it's over with. If that's pure acid, you know what acid can do to your body, right? you know exactly what acid. Acid is something that's above the pH scale of 7. So if it's above pH scale, right? Let's take, for example, let's take somebody throw baric acid at you. If somebody throw baric acid at you, what would happen? It would eat through your skin. It would eat through your flesh, and it would cause your skin to deteriorate, right? Okay, so imagine you deal with the pure acid. That's, again, that's deterioration automatically. Everything's deteriorating. Yeah. Well, all right. Yeah, that's all I got for tonight. I ain't got nothing else to talk about. So with that being said, thank you guys for coming through, watching, and checking out my channel. I'll keep you guys posted Tuesday in the afternoon around 3 p.m. Eastern time. So that's what time I usually come on, around 3 to 4, or between 3 and 4 p.m. Eastern time. Okay. So I'll give you guys the next topic and let you guys know what's going on. Keep y'all posted, updated on information and stuff. You know how I do. And later on, around 10 Eastern, I'll be talking about the R. Kelly situation and all of that. So I'll get into that. But until then, I gotta get going, you guys. I'm gonna just go ahead and relax for the rest of the evening. And I'll reconnect with you all later. Please be safe. Please be careful. And peace. All right.